Hi everyone, I'm Rikesh, a master's student in environmental resources engineering here at SUNY SF. I'm interested in emerging contaminants and how septic systems contribute to the transport of contaminants through groundwater. Septic systems are actually more common than we often think. About 1 in 5 households in the US relies on septic systems. But what happens when those systems are placed in shallow, hydrologically active soils like in the Adirondacks? Do contaminants actually stay in place or are they transported through groundwater towards nearby lakes? So, to understand that, we need to think about how septic systems interact with the environment. In shallow Adirondack soils, septic systems create a strong connection between septic inputs and groundwater and ultimately nearby lakes. At the same time, septic loading and hydrologic conditions vary seasonally, but we still have a limited understanding of how these dynamic conditions actually control contaminant transport. And that has a strong implications for downstream water quality. So to investigate this, we conducted a field study at Arbutus Lake watershed in the Adirondacks. This system includes a septic leach field indicated by the red box located upslope of the lake serving nearby cabins. We installed 9 groundwater wells along expected groundwater flow path from the septic system towards the lake. Wells 6 and 7 are located directly down gradient of the leach field, which allows us to track septic derived signals as they move through groundwater towards the lake. So with this setup, we can directly evaluate both groundwater flow and water quality responses. So to understand how contaminants might move, we first looked at groundwater flow using hydraulic head. What we see is a consistent gradient directing flow from upland areas towards the lake. This establishes a physical transport pathways connecting the septic system to the surface waters. Wells located along these gradients, particularly 6 and 7, are expected to intercept any septic-derived signals. This gives us the mechanistic framework for explaining the water quality data. The next question is, do we actually see the evidence of this transport in the chemistry? To test that, we looked at groundwater chemistry across wells and the surface water. What really stands out is the conductivity. Several wells, particularly 6 and 7, which you can see in the box plot, showed elevated conductivity compared to others. In contrast, pH and dissolved oxygen are much more variable and do not show a clear pattern when it comes to groundwater wells. This suggests that conductivity is capturing a consistent signal, likely influenced by septic inputs. And more importantly, these elevated values occur in wells located along the groundwater flow towards the lake. So when we combine the flow pattern with the chemistry, we start to see a clear evidence of transport from the septic system through the groundwater. The next step in this research is to identify the specific contaminants moving through this system and how that changes with seasonal use and hydrologic variability. That is something that I'm really excited about. So thanks for listening. I would love to talk more about this at my poster during our conference. Thank you.